Hello, welcome. Let's have a look at this question for episode number 26. Still on the tutorial on motion along a plane or inclined plane. So we have 2 kg box is put on a surface of an inclined plane at an angle of 27 degrees with the horizontal. The surface of the inclined plane is assumed to be frictionless. Remember when we start this tutorial, we said the inclined plane surface could be smooth or rough. When it is rough, there's a friction. If it is smooth, frictionless. So that means we are dealing with smooth surface. We have to draw the free body diagram of the box on the inclined plane and label all forces acting on the box. Then determine the acceleration A of the box down the plane and determine the magnitude of force exerted by the inclined plane on the box. Let's see if we can start with the first one, as in making an inclined plane. So there's going to be a normal reaction moving upward. Then there's going to be if the body is moving down, there could be a force upward in this direction, which is friction, which is going to be negligible in the case of this. Then this is going to be the acceleration of the body, or the force which is actually pulling the object downward. So we have that to be mg sine theta, and that theta is what we have as 27 degrees. So mg 27 degree. Then the normal opposite reaction, normal force, the opposite reaction is going to be the mg sine theta, which is 27 degree, and this is going to be the weight of the body. So we can also say this is 27 degree as an angle. So this basically for the A, drawing the diagram to indicate the forces that are acting on the body will be represented by this. Then the second part of the question is asking for the acceleration. Determine the acceleration of the box down the plane. Now, if we watch the episode beginning of the motion along the plane, we talk about the acceleration in two places, as in when the body is moving down the plane, you have its own acceleration, and moving up the plane. So I can just say that as the body is moving down the plane, the acceleration is going to be g sine theta. If you can check that episode that we did. So that will mean that the gravity, I think I've forgotten to indicate, the gravity is 10 meter per second square. So we have 10 times the sine of the angle 27 degree. And if we can put that into our calculator, this will give you, if I can write this at this point, pardon me, it's supposed to be down because of space. I have 4.54 this acceleration, so meter per second square. So that could be the acceleration at which the body is moving down the plane. Or we can also look at the downward force. So down, let me see, or right. So we can say that down the plane, which force is moving down the plane? This is the force moving down the plane. So F equals to mg sine what? Theta. Where that become m is 2g, 2 kg, multiplying the 10, the sine of the angle 27 degree. Let's see what that will be. That will give you 9.08 if I'm moving for 2 decimal places, which is actually 2 times this very one and the force. But we can also say that if I'm looking for force, it is the mass times what? Acceleration. And it is the acceleration you are looking for. Therefore, acceleration equals to the force of the body divided by the mass, which is 9.08 divided by what? the mass of the body, which is what? 2. You come back to 4.54 meter per second square. Let's check that if that will be the case. Yeah, that will be the same value you are going to get. So in finding the acceleration, we can say that the acceleration is moving down. So it is g sine theta. Or better still, we can find the force at which the body is moving down. Then we use the force equals to ma to determine the acceleration, which is the same concept if you want to do that. Then the last one is to determine the magnitude of force exerted by the inclined plane. As the body is placed on the inclined plane, the body is exerting force on the inclined plane. Inclined plane also exert force on the object, which is the normal reaction. So you're looking for the normal reaction, which is these two. If you subtract this from this equals to 0, you get the body being at equilibrium. So let's see how that could also be done. So for the B, looking at for the magnitude of force exerted by the inclined plane will be R equals to W cos, that is going to be, let me just take it the way it is there, so that it will not be any difference. So this is going to be mg cos what? Oh, I think I wrote sine. It's supposed to be cos. Sorry. Cos 27. So this is going to be the force that is exerted by the plane upward. So that means that I should be having m, which will be 2 times 10 the cos of what? 27 degree. That will be 20 cos 27 degree. And that will give you, if you were to put that in our calculator, 20 cos 27. That will give us 17.82 as Newton. So if you put this together, we can easily tell the force that is being exerted on the object by the inclined plane. So these are all to text the concept we have done from, I think, episode 24, where we discuss the body up or down the inclined plane. Like, share, comment, subscribe, and come back for more.